Okay, Shay Live 2 video sessions. I will also be posting the, I guess the straight answers. I don't know, but here we are. So, problem number 1, part A is find the average rate of change. I gave a video earlier on the average value, function value, and the average rate of change and the difference. This is simply change in y over change in x. All of this notation I have here is for your benefit. It is not necessary to go and do any of this on the AP exam. You could simply go, really, maybe the most there if you need to go there. But you can go right to here if you want. Right? Boys, we're using our markers. Okay, so let's try again. Yeah, there and start there. You could definitely start there. But whatever the case, I'm evaluating this at pi and at 0. I be careful with my negatives. I know my trig value is simple enough. And I leave this the heck alone. Negative e to pi minus 1 all over pi. Okay, part B. I lost a point on this actually when I did it the first time, and I'll show you what I did at the end. What is the slope of the line tangent to the graph of f that x equals 3 pi halves? So we take the derivative. We all know this. We have to use the product rule here. Just be careful. Derivative of the first, normal second. Plus derivative of the second, normal first. This is a minus sign in there because it gets plugged in. That's a multiplication sign. It is not. And that's a minus sign because the derivative of cosine. So whatever. Then we evaluate at 3 pi halves. Don't go crazy. 3 pi halves is going to be an exact value here at these values. This comes to 0. All right, do your little sketch, or put it in your calculator for that matter. Minus e to the 3 pi halves and times sine of that, which is negative 1. So this whole thing becomes 0, obviously, and this becomes negative e to the 3 pi halves. That's where I stopped. Done. Nope. The question was, what is the slope of the line? We need to say the slope of the line at this point is e to the 3 pi halves. So I botched that. I lost a point there. All right. Moving on. Part C. Okay. The absolute minimum. So this is an extreme value theorem. We don't need to say the extreme value theorem. We only have to do that when we justify. In this case, we're simply using it, which means because it's the absolute minimum on a closed interval, it means that 0 and 2 pi are fair game for our process. We also have to know when f prime is equal to 0. I've said this before, excuse me. They like to do this where there's a factored ability of e dx here, where they can factor e dx out. We need to recognize that it's never 0 and never negative. Okay, those are two qualities. And we're left simply with cosine of x minus 1, or minus sine of x. Which really means when is cosine equal to sine? And over the span of 2 pi, it's equal at pi fourths, and it's equal at 5 pi fourths. You can do this on a calculator easy enough. Which means we are testing 4 values. We are testing 0. That's our starting value. We're testing 2 pi. That's our ending value. And we're testing pi fourths and 5 pi fourths. Notice the cute pink colors here for the endpoints and the f prime 0. Then it's a matter of literally putting this in your calculator, having the proper windows, and calc value. I could put this in, or I could run this to 3 decimal places. Either one is perfectly acceptable. There's nothing to say you can't use, either one. So whichever is the best. But similar to the last problem, write this out. The absolute minimum value occurs at x equals 5 pi fourths, which is equal to this. All right, don't lose that point just for 30 seconds of not writing. Okay. Part D. Okay. Part D is let g be a differential function such as g of pi halves equals 0. The graph of g prime is given above. Find the value of the limit. So we're taking this limit, as we always have. We're just going to plug in to start. Yawning, sorry. So this becomes this over this. Remember g of pi halves is 0. They gave us that in the very beginning. This works out to be 0 because cosine of pi halves is 0. Therefore, we have 0 over 0. Shockingly, we're going to use the low half rule. Low half rule, we're definitely going to have that. Actually, definitely. It's a strong possibility. So, from here, we take the derivative of the numerator, the derivative of the denominator. We do not do the quotient rule, and we reevaluate. And we already solved for the derivative of the numerator. You're going to see this. You're going to see where they're going back to your previous sections, and you can just gather information. So don't keep your papers scattered. Like, know where they are. So if they say to you, okay, use part A, you can get part A. I'm yawning like crazy. You can go back to part A quickly. Okay, so just keep that in mind. All right. So we then reevaluate the limit at pi halves. This first part goes away. Be careful here. This is negative this, and sine of this is 1 over 2. There's our answer. We do not want to put that on decimal. We don't. It doesn't matter, but we don't have to worry about that. All right. The equation of the line tangent to G at x equals pi halves. So this is an extension of that problem, right? But what it really comes to is, do I recognize what this graph is telling me? And at G prime of pi halves, this is equal to 2. Which means my slope at G pi of 2, or pi halves, is 2. Okay, so I put it right in my equation. Point slope equation, you can leave it right there if this happens to be a value, or you can change it to y-intercept. And part F says, use this equation to estimate the value of g of x at the point x equals pi. Is this estimate an overestimate or an underestimate? Well, first things first, going from pi halves to pi is really not a very good estimate. Like, they probably won't go that span, but if they do, just know what you're doing. And what you're doing is you're using your tangent line equation, and you're evaluating it at pi. So my tangent line equation is y equals 2x minus 1. That means at that graph, at that point, my graph looks like this. Okay? That's all. All it says is my graph. Now I put this in at the end because I knew it was concave down, but if we're talking about a tangent line, that's what we're talking about. And if I'm estimating it, I'm going to plug in the value they want into my equation. In this case, I get 2 pi minus pi, or pi, which means that's my estimate for y. And then it says it's an overestimate because g double prime is negative. Jeepers creepers. Is negative on the interval pi halves to 2. How do I know it's negative? Because g prime is negative, has a negative slope that whole way down there. Now, it is undefined at pi halves, but I'm not concerned what it is at pi halves. I'm concerned what it is on the open interval, pi halves to 2. Okay? So the fact that this is not differentiable at that point doesn't matter. And that's that. Okay?